This is a demonstration of how to factor and graph a polynomial. I don't have all day, and neither do you, so let's get to it. To factor a polynomial of a power above 2, you first have to find the factors of the remainder. In a polynomial like this, the term without the variables is the remainder. Divide that number by the factors of the leading coefficient, like so. The remainder is 6, so the factors are 1, 2, 3, and 6. Divide that by the leading coefficient of 1. This leaves us the positives and negatives of 1, 2, 3, and 6. Let's try 1. Take 1, and put it into the polynomial. This returns 0. This means that this number can be used in synthetic division. This will help us factor the polynomial. Since 1 is the number we're using, write that on the left side. On the right side, put the coefficients of each term in. The coefficients here are 1, -2, -5, and 6, like the polynomial above. We copy the 1 down, then multiply it by the number on the left of the L. We then put the product below the -2. Add those two numbers together, and place it below the line. Take the number, multiply it by the number on the left of the L, and place it below the -5. Add the numbers together, and place it below the line. Repeat the step. Confirm if the last number, which is the remainder, is 0. If it is not, you did something wrong and you lose. Do not pass go, do not collect 200. If it is 0, congratulations. You just factored the polynomial down by 1 degree. The 1, -1, and -6 means we now have a polynomial, x squared, minus x, minus 6, and a factor of x minus 1, because if we put the number on the left of the L, 1, into the x, we get 0. Since this polynomial is small enough, we can factor it without the use of advanced magic. Find two numbers that multiply to -6, and add to -1. 2 and -3 work. -3 plus 2 adds to -1, and multiply to -6. So that factors to x minus 3, and x plus 2. The factored form is, x minus 1, x minus 3, and x plus 2. This means that the zeros are at 1, 3, and -2. Plot that on a graph, because graphs are fun. Now, we need to find the y-intercept. Since the y-intercept is at x0, we can do some magic to figure out where it is. Put 0 into the factored polynomial, and we will find the y value when x is at 0. What else is at x0? The y-intercept. The y-intercept is at 0, 6. Make a mark there. Now, we have nearly enough information to draw the graph. But let's fill in some missing information, so that our graph is more accurate. We know the y-coordinates when x is at -2, 0, 1, and 3, and we know that a degree 3 polynomial can have two turning points. Since the leading coefficient is positive, we know that the polynomial starts on the bottom left quadrant, and leaves on the top right quadrant. This means we do not have to worry about values beyond the zeros. However, between -2 and 3, we are missing the coordinates of two values, that of -1, and 2. Take those numbers, and put them into the factored polynomial, and it will return us the y values. Plot them on the graph. Follow me. Now that we have all the points plotted, all we have to do now is connect the dots. Remember that the domain and range are infinite, and thus exist beyond our graph. Don't forget to put arrows on the ends of the line. We have graphed a polynomial in under 5 minutes. Congratulations, give yourself a pat on the back.